another real number. Okay, is an accumulation point of X if and only if. So-called if and only if means the definition. Okay, means if the following condition is satisfied, means this one is a accumulation point. If for any epsilon greater than 0, there exists at least one point T of X. Now S is a set, right? A set of real numbers. If there is one point in S satisfying T minus S0 less than epsilon greater than 0. When you first time study this definition, it's not easy to understand. For example, when I was a student, it's not easy. So when you take more time to think about, to analyze this definition, last Friday, on Monday, this Monday, I cleaned my teeth, but now it's still painful. The student, right? By the way, next Monday, I can only talk half of the class. Means I will stop. I talk earlier. My cleaning up my teeth is not finished. Continue to do earlier. So for example, at most 2:50. Oh, that is a probability class. Now, what does it mean? Let me give you some explanation. So-called accumulation point, if this is an accumulation point, means what? Means for any epsilon greater than 0, here, just like the definition of the convergence or of the limit, here, although we say for any epsilon greater than 0, but the actual meaning that we want to express is for any arbitrary small positive number. This is a positive number, right? But we really mean that for any arbitrary small positive number. Means no matter how this epsilon, how small this epsilon is, how small, but it's positive, okay? It's very small, for example, 0.1, 0.001, right? This means very, very small. No matter how small it is, look at what's this. This is, based on our definition, this is a deleted neighborhood of S0. Deleted neighborhood of S0, right? S0. T, if T is a variable in the neighborhood. This means what? This means no matter how the neighborhood of S0 is, there is always some number in this set that is located in this neighborhood. Now let me try to describe the definition in another way. Okay. So-called, if we have a, okay, this is a set, right? This is number 9, right? Now we have a lot of numbers in this set. Now if we say, for example, if we say this point is S0, we say S0 is an accumulation point of X, means what? Means we just draw any neighborhood of S0, okay? Any neighborhood. No matter this neighborhood, how small the neighborhood is, there is always some numbers of this X in this small neighborhood. If for any small, arbitrary small neighborhood, there's always at least one number of S located in this small neighborhood. That means S0 is an accumulation point. Anyway, this is abstract. In order to help you better understand it, we can use example. For example, this is the same thing, okay? I claim that there's one and only one accumulation point for this set. Can anybody tell me what's, based on your understanding, what's the accumulation point? It must be a delete neighborhood, right? Because here is greater than 0. It's a 0. Actually, you can see that, like I can tell you earlier, right? It's a limit, right? You may say, this is just a limit, God. Why do we want to learn accumulation point? We just say limit, that's it, right? The point is, a limit is always an accumulation point. But an accumulation point may not be a limit. For example, let an equals, okay, 1, 1/2, 1, 1/3, 1, 1/4, 1, 1/5. Now you can see what this sequence is, right? Every other term is 1, and every other term is 1/n, and something like that, right? Now look at it. Obviously, this sequence is not convergent, right? It neither converge to 0 nor converge to 1. Actually, the limit doesn't exist. Can you see it? Right? Because this subsequence, now we will introduce subsequence later on. This means subsequence converge to 1. Another subsequence converge to 0. So this sequence has no limit, okay, but it has an accumulation point. What's the accumulation point? This time, can you tell me?
0.
Still 0. Still 0. Now, is 1 another accumulation point? No. Very good. The reason is this deleted neighborhood that's greater than 0. If 1 is an accumulation point, then 1 minus 1 is 0. It's not, right? When we say now we have. Let me see. Can I prove this one? Okay, prove this one. I want to prove this sequence has the 0 is an accumulation point based on definition. Okay, I claim 0 is an accumulation point of S. If I want to prove it, I need to base on definition. Okay. For any epsilon proof, any epsilon greater than 0, there exists at least one point of S, such that the inequality true. Right? Just like we prove the convergence or limit, right? With analysis. Suppose we claim that 0 is a combination point, means this is 0, right? This is 0. And here T, what is T? T is an element in S, right? But any element in S can be written as 1/2n, right? Then the S0 is 0. If we want this one less than epsilon, right? For any epsilon, if this is true, this just means 1/2n less than epsilon. Right? Now, if this is true, means 1/epsilon less than 2n. Right? Now, from here we get n greater than log 2 1/epsilon. Right? Right? This exponential function, take a log, you get n. Log 2 to n, just this means log 2, then 1/epsilon less than log 2 to n. But this equal to n, right? Means what? Means as long as n greater than this number, then this is true. Then this is true. Okay. So prove for any epsilon greater than 0. Pick once again. So-called there exists. You need to pick it, right? pick n, or n star, whatever, okay, greater than log 2 1 over epsilon, then a n star, okay, minus 0 less than epsilon. For any epsilon, but pick n star, this is less than epsilon. Means what? Means for any epsilon greater than 0, we can find a n star. A n star is an element in the S, right? We have this element, this is T in S, right? Such that T minus S0 less than epsilon. So 0 is an accumulation point of S. Okay. So this is the proof. But from now on, we do need to use the epsilon language again. Okay. Because this is a definition. Definition contains an epsilon. So we can use it. Okay. That's what we do. Okay. Next time, let's do continue.
So does S0 have to be an element of S, or does it not have to be?
Doesn't.
It doesn't.
Good question.
Okay, I was just looking at it. I was
Yeah.
wondering, like, wait, zero's not a part of S.
Yeah. Doesn't. Yes. Alan.